Okay. All right. Hi, everyone. Good morning. So I was just getting the lowdown on Eric's card collection. He's knows a lot of restores old antique cars. So it's pretty interesting. If you ever have time, you should pull him aside and have him give you some background on that. But looks like everyone's getting signed on here, and I'll jump in here and introduce you, Eric. Thank you for joining us this morning. So Eric Snodgrass, I think a lot of you are familiar with. He's a principal atmospheric scientist for Nutrient Ag Solution, where he develops predictive analytical software solutions to manage weather risks for global production agriculture. He provides frequent weather updates that focus on how high impact weather events influence global agriculture productivity. So I think this is maybe the third or fourth year in a row now we've been doing this. And so we appreciate you, joining us, and you do a good job. So when you do a good job, you get asked to do it again. So we appreciate that. So I know we got viewers from all over the Midwest, and as we go on, if people have questions, there's a place there in the Q&A box. You can go ahead and type that in. Don't wait until the end. Sometimes those questions take a little while to type in and to think of. So just go ahead and type those in as we go along. So Eric, without further ado, I'll hand it over to you. I think you can pull up slides if you want to. So
yeah, well, I appreciate the invite back. And for those of you that are now able to hear, we were actually talking a bit more about what's going on in Russia and Ukraine, and just the chaos of every time there's a little shift in that war, and what it's done to the prices and what it's done to oil and energy and things like that. And it's interesting. I was going to start off just going straight into North America, but maybe I'm going to do a quick detour and give a quick update on South America first. And then we'll jump into the stuff I've got for your outlook for spring and summer. And I welcome the questions, but you're going to see a lot today. I like to give a full story on everything I'd like to share. And I think one of the things I want to make sure that you walk away with today is this, okay? When we think about this upcoming spring and this upcoming summer, after I cover South America, what I want you to remember is so much of what you're going to see in these forecasts is going to be built on two things. And if you walk out of here today knowing those two things, specifically what's going on with our current drought, and then what the ocean temperatures kind of give us a clue about what to expect, that's the big takeaway. I'm going to provide you with a lot of resources, a lot of great maps. I'm a map guy, so you get to see a lot of great stuff like that. But that's it. When you leave here today, I want you to see those big picture things. All right. Okay. So great. We've got quite a few people on. I'm just going to go ahead and start sharing my screen here, and we'll come back to basketball in a second. I promise. I'm going to get down to these slides right here. Now we're going to do this pretty quick. All right. We had a major drought earlier in the year in southern Brazil. This story's already played itself out. We know that drought in southern Brazil hit about 40% of the crop, while it was pretty wet in the north. And the forecast of that was pretty good. But by the time we got to mid-January, about midway through the season, the drought extent in southern Brazil, Paraguay, Uruguay, and Argentina was some of the most extensive that I've seen in my career, and for some places here since we've been keeping weather records. In fact, by the time we got to mid-February, there were actually fires in southern Brazil due to how dry it was. Now, a big story about all this is that it pulled back total production from what could have been the biggest crop ever, which is always on tap for Brazil in each given year, but it pulled it back about 25 million metric ton. So all that damage is done. That's in the past. Markets have already played this out. We know, I think, what we're getting in terms of soybeans. So then what's interesting is that since January 17th, when the drought extent was the greatest, till just a couple of weeks ago, about mid-March, we really worked hard on eliminating that drought. And these two maps I keep showing you here, these are root zone soil moisture maps. So it gives us an idea of how much moisture is there in the soil now. So major drought relief, but it came in the form of some pretty nasty severe weather coming out of parts of Argentina first. So just, oftentimes drought breaks on big severe weather. And this is what we saw there. Some of the big hailstones that hit parts of Argentina near Santa Fe. That's on the Paraná River, which was nearly dried up at one point this year. And then in northern Brazil, where they were trying to rapidly harvest, they did run into a few problems. I think there's some weed pressure in here, and also maybe harvesting a little too green. But the thing I want to tell you is they got that soybean crop out fast, which means that this safrinha crop, the second crop, went in quick. And this is where we'll finish with South America. All right. You can almost take what they saw at the beginning of the season and flip it over, and you've got what they've had since then. So let's start over here on the left in this map. This shows you since late February to about 4 or 5 days ago in March, what the drought indicators look like. So what you see here is we've now developed drought in the areas that were super wet early. I'm talking about Minas Gerais, which is here, Goiás, parts of Tocantins, but also Bahia, and a corner of Mato Grosso. Now, why we have to think about this is come down to the map that's down here in the bottom. That's their safrinha, or second season corn crop. About half of it, to be honest with you, about half of it's grown in Mato Grosso, which is here. And the crop in Mato Grosso is fine. It went in quick. We're not talking about stresses there. Where I'm concerned about is over here in Eastern Brazil's growing areas. When you add that area up, plus some of the areas that have been very wet south, like Paraná right here, they've not exactly been able to put the crop in quickly. It's been quite wet. And then north, it's been dry. So if I had to put a number on this, I'd estimate about 20% of Brazil's second or safrinha crop has been hit by some form of adverse weather, either drought or too much rain. And if you were expecting this second crop to be somewhere in the vicinity of maybe 3.1 billion bushels or maybe 112 million metric ton, that might be just the very top end of what they could produce. And if we continue to see drier conditions here as we go forward into the end of March, into April and May and June, this is going to hit this crop as it tries to get harvested. And they won't start harvesting this for another at least 6 weeks. And they usually get it all done by June. That's when it's out. So I just want to keep you aware of some stuff that's happening internationally here, especially in South America. But it seems like the major players today, as Matt and I were talking about, are really happening in crude oil, some stuff going on in China as well. And that's really wreaking just a lot of havoc on the markets. All right. So why don't we go from here? And I'm going to switch back to the beginning of this talk where we're going to talk a bit about basketball. I love this time of year because of the tournament. And there's one of my favorite websites called 538.com. You should go check this one out. 538.com has an NCAA bracket where you can hover over any team at any point in the tournament. I chose the beginning of the tournament and see their probability of winning it all. All right. Now, the reason why I'm showing you this is because the NCAA tournament, if you think about it, how many millions? It's like almost 30 million people fill out a bracket. And those 30 million people have access to every player statistic, every coach statistic, every team statistic. They know how they've played, what they can do. They know the teams inside and out. So you make a bracket, you start picking who you think is going to win. Now, before the whole thing started, Gonzaga had the highest probability of winning at 27%. They had a 62% chance of getting to the Final Four. And when you look at this, what I want to tell you is when we forecast the weather, it's kind of like forecasting a bracket. You have your big players, your Gonzagas, your Kansases, the big teams that when we look at the atmosphere, we might call El Nino, or we might call it the global wind oscillation, or we might talk about the Pacific jet stream behavior. But then you also have your teams in the tournament like St. Peter's. I know you've all heard a lot about St. Peter's lately, but look at these stats. St. Peter's had a 5% chance of beating Kentucky. And early this morning, I had to give a talk in Kentucky. They were not happy to see this particular figure. But, it's amazing, right? But St. Peter's did it. And then they did it again. And then, just to see them advance as far as they advanced tells you that sometimes these, what seem to be small factors or features or small mid-major schools do things that's unexpected. And the atmosphere is full of all of this, be it a polar vortex disruption, be it something like a shortwave that cuts over Texas and ignites a bunch of severe weather in the south, or something like at the wrong time of year, a small feature in the Gulf of Alaska, a ridge, develops and completely changes the precipitation pattern across the Corn Belt. This is what we deal with. And I think the NCAA tournament is just a great example of how predicting these things is tough, because halfway through the first day of games, there was less than 5 perfect brackets left. So just understand how difficult it is to predict nonlinear chaotic systems, be it the NCAA tournament or be it the atmosphere. Now, I titled my talk today, I've left this title for the last week. I love it. It's Greek. What you've got there underneath the big nutrient in is the word tropos. And in Greek, tropos is important to atmospheric scientists because it's a word we use a lot, because the word tropos, when translated to English, means overturning. And the atmosphere is about to do what I call its greatest trick every year, in that we come out of winter and it just prepares itself to completely overturn. And I'm going to explain to you why in just a few seconds. Real quick, though, I'll be sure to put this in the chat as well. I do give out a free daily report. You can find it by going to that web link that's down there at the bottom. I'm sure many of you on this call get it. It comes out 5 days a week. It's a lot. You know, you'll get it every single morning. If you don't want to read it today, just delete it. I'll give you another one tomorrow. You can take a look at that one. But it's a national picture of the weather, and it keeps you up to date on all the big picture things I'm talking about now. Plus, I hyperlink everything in that report. So if you want to build your own kind of repertoire of links of weather stuff, you can have everything I have. It's right there in that report. I just want to make sure that you all get access to it. All right. So why is the atmosphere going to overturn? It all comes down to this great figure put together by a colleague of mine, Brian Bretschneider. He's a great follow on Twitter at Climatologist49. He's actually from Alaska. And what he made a map of here was during the month of March, how much additional daylight is gained from the beginning of March to the end. I know, Matt, you're in Iowa, but we're looking here at somewhere almost an hour and a half of additional sunlight. And I want to show you what the atmosphere does with that. Ready? So in the middle of winter, if you look at the way the temperature changes as you go up in the atmosphere, it's cold at the surface and it's cold way up here at the top of the troposphere. And because of that, the atmosphere doesn't overturn very easily in winter. But in spring, the temperatures climb, but the upper atmosphere stays cold. And that uneven heating, where it's hot at the surface and cold aloft, just forces the atmosphere to do this. And it just explodes. And all that a thunderstorm is it's a mechanism by which the atmosphere takes heat from the surface and sends it up in order to equalize the temperature distribution in the atmosphere. The thing about Earth's atmosphere is it's full of water, which means when we cause air to rise and overturn, you get condensation and clouds, and those clouds produce ice. The ice gives you all the lightning and thunder. And if it does it all violently and starts to spin around, you can produce some of the most impressive and massive storm systems that we've found on any planet we've ever explored via from telescope or landed on. So when you think about all of this, it's just a neat way to kind of understand what the atmosphere is about to do. And I want to talk with you first today about some severe weather things. So last week, this is what we saw. Those Rocky Mountains over there to our west, as the flow comes over the top of them at the jet stream level, we often produce these big low pressure systems. And this was a week ago, right about now. Deep low formed right here. And it just had a big high pressure system complementing it over on the East Coast. And we were just funneling in the moisture. And as a result of this, the atmosphere just unleashed first in Texas. You go back to the 21st of March, and what you can see here, that right here on our first full day of spring, all the severe weather that set up there in eastern Texas that eventually moved over the lower Mississippi River Valley and continued east. Now, I paused the video right here because I'm going to tell you, I got two big things you need to learn today. I want to talk about where drought is, and then we'll talk about where drought's going. And can you see all of the dust that's in the air here in western Texas? You see, we're split right now in the country where there's tremendous amounts of drought east. Tremendous amounts of drought west. And we're really, really wet east. And it's been big thunderstorms like this one that produced this tornado here. Brandon Lane took this picture. He storm chases out of Indiana, but he was in Texas for this one. And by the way, you can see they got soybeans coming out here. They're going. They got crop going down here. And Brian Empfinger caught some of the tornadoes as they went through eastern Texas. And I love this video because it illustrates an important point about severe weather. You're about to see it here. Now, the tornado, you can't really see it well because it doesn't have a lot of condensation in it, but you can see the damage. See this mobile home? Gets ripped to shreds. Now, that same tornado is now going toward this permanent home. Same tornado, same strength, hits the permanent home, tears the roof off, and there goes all the insulation. But all four walls still standing here. And it just brings to light a very important point, and that is that 45% of all tornado deaths are in mobile homes. 10% are in permanent structures like this home here. And this is just a great video to illustrate what these tornadoes are capable of doing. I'm sure that you all saw this on the news, but this is an incredible video. In the middle of this tornado, there's a pickup truck. Can you see right there's a Chevy, gets rolled over by the tornado winds, spun around. The wind then catches inside of the back of the truck, flips it back over, and the kid who's driving in this thing just drives off. And apparently he was featured in a couple of news stories. I didn't get to catch him just yet, but I would have loved to have heard the story. You had to tell mom and dad about what happened to the truck that day. But thank goodness the kid was all right. This is what things have been
Eric,
like.
I don't mean to interrupt you, but I was just going to mention Chevy gave him a new pickup for that.
Oh, did they really?
Yeah. So he had a rough ride, but it ended up okay for him. He got a brand new pickup for that.
Oh man, I need to roll my Dodge and see what happens. That was crazy. I did not know that. Like I said, I have been living under a rock, it feels like, with news lately. So I didn't hear if that kid, whatever happened to it, but he clearly drove off and now he's got a new truck. But by the way, staying on back to a more serious note, I should say, this video was out of New Orleans on that second day of severe weather. And you can see that massive tornado ripping through New Orleans. And they don't often get big supercells that produce tornadoes like this. Now, why are we talking about it? Well, it's that time of year where we think about the protection we've got for these severe weather events, whether it's severe weather, whether it's flooding, because after all those storms went through last week, you got this guy out here, just stepped outside of his mobile home there, do a little fishing. And while I personally can't wait to do fishing myself, this is not the type I'd like to do in the floodwaters around my house. So just incredible to see what these storms ended up doing. But here you go. Let's give you some data here. By the end of the year, we typically accumulate, see the black line here, about 1,400 reports of tornadoes. And the black line is the average rate at which we accumulate the reports of them. And what you can see right here is that we're currently sitting well above average, and we're about to go into that time period of the year where we have a lot of activity in terms of severe weather. So we're just now entering it and we're already above average. And what's important to see here is that we've had two big spikes on this red line showing you the 2022 data. And that first one was down here in early March when we saw this massive tornado rip through parts of south central Iowa. And this is what we call a multi-vortex tornado. So it has several smaller circulations within the larger funnel cloud, and it did a tremendous amount of damage and unfortunately claimed several lives as it went through there. Now, just to bring an important bit of research to light, I've been showing this since last summer. I'm going to put it in every presentation so that everybody can see it. But a good friend of mine named Victor Gassini, he's out of Northern Illinois University, which is about right here. He published a journal article in the journal Nature, where he looked back to 1979 to understand how the ingredients that come together to make tornadic thunderstorms have been changing. And essentially what he found is when you get over here into the Mississippi Basin and east, this is an area that over the last 40 plus years, there's been an increase in tornadic thunderstorm activity. He's looking at ingredients, but that's what's changing. So the risk of severe weather is increasing farther to the east. It's still here in traditional Tornado Alley. Don't get me wrong, but the risk is just increasing farther to the east, and it's really increasing in the Mid-South. And this is just some important research that we need to keep an eye on because that trend is robust. It's statistically significant. And if you get a chance to read his paper, it is a well-written paper on what this risk looks like. So I would encourage folks to take a look at it. What about hail? Well, last year, see this line over here, we were at less than 50% of normal on hail. And so far this year, it's been a slow start to the accumulation of hail reports. But often what happens when you break a drought in the central plains, you tend to get a lot of hail. That's that dry air that's needed in the mid-levels of the atmosphere to give us really cold conditions aloft that we would need to make a lot of hail. So I do not anticipate this year being anywhere close to last year, which was record low on hail reports going back to 2005. We've already had big hail. This was the same storm that went through Iowa there, put down some baseball-sized hailstones. And just so you understand, these stones will fall from the sky at about 150 miles an hour. So they can do a tremendous amount of damage when they hit. So again, that was out of that storm system in Iowa back in early March. What about wind? Well, we're right on pace for our normal wind report, accumulation of wind reports. You see the blue line matches up with the black one. But just so you understand, our chances of getting severe winds versus hail versus tornadoes has a much longer season. It tends to go much later into August and September than we do tend to get the hail reports or the severe tornado reports. So we need to watch out for this carefully. It's going to be another year where I think we're going to be watching out for a lot of wind. We got a system coming up. in the next 48 hours, that's going to add a lot to these numbers. Now, I'm going to come back to the main point I got to tell you about today, and it's a story about drought. You see, before all of that severe weather I just shared with you that happened in the South in the last 10 days or so, it was burning. This animation shows you Eastern Texas. Look at all the fires. Look at Western Texas. This is on the Cotton Belt. Right here from Lubbock to Amarillo. I mean, this is big time cotton country, and they had a huge dust storm in there. Now, the severe weather came through, and then after it was done, I caught this video just the other day. What you're looking here is some of the fire reports from over the weekend. Look at this is around Dallas is right here. Dallas Fort Worth is in this area, so you're south of it. But take a look at the large fires that were putting out all that smoke. So the point to say here is some of the recent rains have not cured the drought issues that we've got in this area. And as I stated earlier, I need you to walk out of here today or leave today from this webinar remembering really two big things. And the first is this map right here. Now, the Drought Monitor is a product out of the University of Nebraska at Lincoln, and it's a great product. But the Drought Monitor is built on something called the Palmer Drought Severity Index. That's part of it. And that is a cumulative statistic, which means the Drought Monitor often doesn't change dramatically every week because it's looking at the longer term drought stress. So you notice there's drought across parts of Iowa, northern Illinois, southern Wisconsin. There's sustained long-term drought in the southern plains through Nebraska, getting up into Montana. And the West is getting drier and drier and drier. But I want you to remember this. We've currently got about 70% of the land area in the lower 48 in some form of drought. And all of these long-range forecasts that I'm going to share with you in just a little while here, every single one of those long-range forecasts was initialized with drought in place exactly where you see it. Now, you might be asking, well, is there a good year I could look back on and say, oh, it looks just like this year? Well, the reality of it is we can't. The Drought Monitor only goes back 22 years. And I looked back at every single March since then. And the drought situation this particular year is unique in its coverage. We need to keep that in mind as we go forward. Now, what I like to do every week is when the new Drought Monitor is released on Thursday, you can go into the Drought Monitor website and click on Change Maps, okay? The Change Maps drop-down menu. And this is what I want to share with you. So please make sure you take this idea home. We've seen some of the drought expand into South Dakota. I'll show you the statistics. It's been getting drier into Montana. If it continues to press into Iowa or out of Kansas into Missouri, out of Oklahoma into Arkansas, such as that drought area looks something like this, or even like this, once we get into June, then the jet stream this summer will run over it like that. And that means if you're in the eastern Corn Belt into the southeast, this little area over here, lots and lots and lots of storms, maybe in the Canadian Prairie, through parts of Minnesota. But what ends up happening is if the atmosphere builds drought in this area, it likes to put high pressure on it in the middle of summer, and the flow just goes around it. And that would be the most, I guess I call it the worst case scenario for much of the Corn Belt. That would be what I want to look out for. Now let's give the flip side of this. Let's imagine through April, because it happened last year, let's imagine we start to beat back this drought in this area from Western Iowa. Let's even make it larger, this whole region in here, such that we now push the drought back toward the southwest. If that's the case and the ridge sets up here, then the flow comes over the top of it, and we end up going into one of those years that has a lot of thunderstorm activity across the Corn Belt. Tends to do very, very well with respect to yields, although we have to deal with some of the damage of those storms. Those seem to be the two most likely scenarios I'm seeing this year. And I'm going to explain to you why I think those are the scenarios, because you notice I didn't talk about ridging in the southeast. I didn't talk about, other particular patterns that can cause trouble. I'm really looking at drought here or drought here. I'll show you why. Currently, our 40 centimeter or 16-inch soil moisture numbers are very low from Texas through western Kansas, through most of Nebraska, western Iowa, and South Dakota. We've also seen some drier conditions at times over toward the Appalachian Mountains, and even in Kentucky, believe it or not, there's a couple places that are drier here. We've seen this drought expand into Montana, and this is a place right now. I've talked to many growers up here, and they're already, some of them are just tossed their arms up and just said, I don't know what I'm going to do. We did not get the moisture we needed this winter. It was super windy. I mean, incredibly windy. And the temperatures fluctuations were just incredible. They'd have up to 80-degree swings in temperatures inside of 1 week. And there's problems in the West as well. We think about some of the bigger issues here, and I think about snowpack through the equinox. Much of the Missouri River Basin, getting over here to northern Illinois, Wisconsin, this area, this is a region that saw between 10 and 60% of normal snowfall. So a large area through here missed out on a lot of critical winter moisture. It's not much, but there is moisture and snow that we could be using. What about the stats? Now, this is a map I've been excited to kind of show you because I think there's a lot of information in this map. This comes out of Iowa State. And what you're looking at here are ranks. So this is just another way by which we can define the haves and the have-nots. So from January 1st till yesterday, there's a number inside of every climate reporting district. Since we have data that goes back to 1893, you get a rank. So you see the 130 in Nebraska there? That means it's the driest start to any year on record right here. Same thing for California, Nevada, parts of Southern Oregon, Arizona, Utah. And the dryness, I know it doesn't look right, but the dryness extends much farther into Montana. That's a big climate district. It really goes all in through this area. It's also down here. And while it's been so dry in these three corridors, super wet here. Now, I'm bringing this up and making this point because in just a few minutes, we're going to see where the forecast is going to go. And our models have a problem. They are very sensitive to initial conditions. In fact, all models are sensitive to initial conditions. So what I'm going to tell you is what I'm about to share with you in a few minutes is that the forecast going forward is likely going to mimic what we have recently seen. Whether it's right or not, that's one of the major caveats to using these models. That's my first of two big bullet points today. Please keep that in mind. Now, when we think about how rough drought is in the West, I just want to show you something. Snowpack right now is currently sitting between 31 and 43% of normal in the mountains. These are the mountains in California, the Sierra Nevada and the Klamath Mountains. Lake Shasta, their biggest reservoir, is at 38% of full pool. Orville is at 47. The Drought Outlook, everywhere that you see this color, I'm kind of hovering over here. This is where they are not expecting drought through the end of June to improve. Now, this isn't going to be perfect and exact and right. But what it's showing us here is that not only are we concerned about it, but NOAA's concerned about the extent of the drought in the western part of the United States and what it's going to look like once we break fully into thunderstorm season. I'm going to tell you what I'm going to be looking for. Now, since a lot of you, just based off what Matt and I were talking about, a lot of you are Midwestern farmers. The most feared weather pattern for Midwestern farmers is this. Anybody west, you fear the Rex block. Now, let me show you why you fear this. I went in, let's look at this map. I went in and I looked at some really dry years for parts of the Corn Belt. I've listed them out here, like 83, 2012 is on the list. You know, you've got 91. You see these years that have jumped out here? I've only picked years, you know, the big dry years. Now look, when we have problems, here is the key. So listen carefully, okay? We have problems when there's a trough of low pressure in the Gulf of Alaska. Now you say, why is that a problem? Well, this is where the jet stream begins. And the winds come diving in like this. And then they bounce, they roll over the top like that. What ends up happening is right here in the Midwest, we produce a big area of high pressure. The jet stream goes north. And that's what settles in those big droughts that we saw in like 12 and 80 and 83 and all these other years you see down here. The key is right here, the Gulf of Alaska. Now look, the years that give us such hot and dry summers oftentimes have cold water in the Gulf of Alaska. You know, you hear a lot of atmospheric scientists, you hear a lot of meteorologists talk about how La Nina and El Nino are so important. They are in winter and in spring, but not in summer. The correlation between La Nina and El Nino with summer weather patterns is not as strong as the ocean temperatures in the Gulf of Alaska or off the Baja, which means that these waters get colder than they are now. That increases the risk in the midsection of the country for drought to continue to develop. Now, let's talk more about that here in a few seconds. What about the flip side? I went and now found a bunch of wet summers. Look at all, I got them all listed down here. There was a ridge here. So the digestion went over it and then dove here. And that's what brought in better moisture to the Midwest. What happened to the ocean temperatures? It was warm there. See that? That's our strong signal. Now, stuff that away in the back of your mind, because I'm going to come back to that again in just a few minutes. All right. You want to know what happened last year? The ocean temperatures got warmer and warmer and warmer in here, leaving some cooler water down there, but it kept getting warmer by the time it got out to July. So the atmosphere responded in kind by putting a big ridge of high pressure here. Now, the issue with this ridge of high pressure is it extended pretty far into the Western Corn Belt over to this part of the country. It hit Canada hard. Throughout the Canadian prairie, this was 2021 on the right, 2020 on the left. Driest summer since 1979 in the Canadian prairie. Wildfires ripping across the western part of the United States last year. Didn't burn as many acres as it did the year before, but the wildfire smoke in July and early August was just prolific. We were measuring it across the United States here using one of our high resolution models. We found that through the I-states and surrounding states, really the whole of the Corn Belt, that throughout last July, 15% of the direct sunlight was eliminated and made to be diffused by all the smoke in the atmosphere. You probably remember this by seeing those really, really deep red sunsets that happened when we got into the month of July. That's what happens when you put that much smoke in the atmosphere. But you can see where the ridge was. This is the same style map as I showed you before, but now we're looking at temperature between June 1st and August 15. Everywhere that had the number 1 in it set a new record for the hottest summer time period. It tells you exactly where that ridge sat. When you think about it, we can look at precip. And last year through mid-August, we were extremely dry in the Western Corn Belt and very wet in the East. That's the proximity to the ridge driving the weather patterns. The ridge was here, the trough was there. That's it. So every year, it's me trying to find where this ridge axis is going to be. Is it going to sit over the Midwest or is it going to sit over the West? Or is it going to sit over the Southeast? Where's it going to be? That's the goal of every long-range forecast right now. By the way, we also have those sneaky systems we call tropical cyclones that come in and disrupt things as well. Last year I had 21 named systems, but one of them that cost $75 billion was this one right here. It's Hurricane Ida. Ida was Category 4 in intensity as it approached Louisiana. And as it did so, we took offline all of our natural gas and oil extraction that goes right in through here. And also all the refining facilities that are onshore, they were pulled offline as well. There was a lot of damage to the infrastructure. And this hurt nitrogen production, and it also hurt glyphosate. We have glyphosate producing facilities down here. When it came through, it produced a storm surge about 10 feet deep, and it produced winds in downtown New Orleans, look something like this. Now, I'm not sure if any of you were downtown New Orleans for Commodity Classic, but that's the Regions Bank down there, big building. I'm sure you saw it if you were down there, getting buffeted by winds that were approaching 85 miles an hour, just loaded with water. But since last August, when this happened, I have been showing those movies and this figure because it just blows my mind. You see, the normal discharge rate of the Mississippi River is around 350,000 cubic feet per second. But this particular river gauge in Louisiana measured a negative discharge rate in when Hurricane Ida passed over the top of it, meaning that Hurricane Ida's winds stopped the flow of the river. Just incredible to see that. We're still feeling the ramifications of this hurricane with respect to its disruptions to our supply chain going all the way back to this past summer. Now, when we got into winter, and this is where we're going to break away and start doing a forecast here. Throughout winter, the beginning of it, December, there was a big ridge that sat here. So it just funneled in all that moisture out of the south and the heat. And we had a very mild winter for many people across the United States. Because of that, we saw multiple severe weather outbreaks. This was the severe weather outbreak that happened on December the 10th. You're looking at over 750,000 lightning strikes as observed by blitzertongue.org, a great resource to monitor lightning strikes. When it went through, our radar network captured all of it. And you can see here the squall line that went ripping through parts of the Mid-South. As it did so, it produced over 400 reports of severe storms at that particular moment. We caught some of this on video, And this was the video of the Mayfield, Kentucky tornado, as you see here, lit up by lightning in the background. But since this was an event that happened at night, we had to rely entirely on our radar network in order to observe and forecast where these particular storms were going to go. But this image right here will now be showing up in every weather book that we'll use in colleges and universities all over the world, because the hook echo seen in the planar view down here was nearly textbook perfect. And this thing you see going up in purple, that would be the tornado itself, lofting debris up to 30,000 feet. Some of this debris was thrown as far away as Louisville, Kentucky. Incredible to see that. The atmosphere then repeated itself again 5 days later. Big ridge sat up over North Carolina, funneled the moisture right here into this new low that popped up in Colorado that took 12 hours to go from Colorado to the Great Lakes, because the leading edge of these storms ripped through between 60 and 90 miles an hour. Now tonight I'm going to drive I-80, but a week ago I drove 30 here in between Ames and Cedar Rapids to see the additional damage done after the derecho of 2020 by this December 15th outbreak of severe storms this year. When it was all said and done, we had nearly 700 reports of severe weather in this area. And had this happened when there was a crop in the ground, we would have measured 50 million acres of damaged crop right in the heart of the Corn Belt. Thankfully, storm systems like this often don't happen to this magnitude during summer. They tend to be a cold season phenomena when they do occur. But I come back to my main points. This is what everything looked like on satellite on that December 15th event. And as I let this play again, I want you to see what I've been watching since winter started. Do you see it right here? All of that is dust getting picked up out of Colorado and Kansas. That tells you how dry things are to the west. And to the south of there in Oklahoma, this is all wildfire smoke mixed with dust. So my point here is to tell you that all winter long, instead of seeing the undoing of drought, we saw drought expand. We've had it peppered with nasty, severe weather events. But we come down to one important idea today. There is drought in place, bullet point number one. And all of our long-range models are going to see that, and they're going to let it persist. And I'm going to explain to you the folly in that in just a second, okay? All right. Jet stream position this winter. Now, see if you can stitch together some of the things I've taught you. Since the beginning of the new year, January 1st up until just a couple of days ago, look where we've had a ridge. So the jet stream has to go over it and then dive here. Now, why is this important? You see, it's when the jet stream makes the turn at the base of the trough that you have your best upper level support for making precipitation. Not when it's coming out of the northwest. In winter, that gives you convergence, and that just ruins the chances of precipitation. So because the ridge has been here close to California, the weather systems have been coming out of the northwest. And if they come out of the northwest, it makes it dry in this area and wet in this area. The perfect scenario, if we wanted to eliminate all drought, is to get rid of this and get the jet stream coming in like that, straight from California to Maine. Unfortunately, when it does that, if it doesn't stop, you get a repeat of 2019. So it's always a battle. What are we going to see? But I need you today to remember, your point from now going forward is watch the ridge. Is it going to be in the Gulf of Alaska? If it's there in summer, we'll do great on precipitation. If it's not, we have to look out. So let's talk about this. So far, year to date, you can see the places that have been dry and that are getting drier. Western Iowa, Nebraska, South Dakota, getting into Montana, the Southern Plains, and the whole of the Western United States. While the eastern part of the Corn Belt has seen 100 to up to 200+% of normal precipitation. So we examine this map and we start to forecast. Just in the last 48 hours, we've seen a breakdown of the pattern. The jet stream right now, today, is screaming across the Pacific, and this trough just came through California. That's the first time going back to December that we've seen a trough come through California. Questions we're asking is, are we going to see more of these? Are we going to see more of these or not? Let's start to get that answer. First of all, that trough by the middle of today is going to produce a deep low here and string a front to its south. And we're going to have a lot of severe weather on that front. It's going to come right up here. I'll show you where. Strong northerly winds on the backside and very strong winds out ahead of it. We've got today red flag warnings, high wind warnings from Texas all the way to Kansas, wind advisories from eastern Texas to parts of the Ohio River Valley. And we've got winter weather advisories north. And that's because as this system goes through, it's going to really increase today the risk of fire here. In fact, there's an extreme fire alert put out by the Storm Prediction Center today for the panhandles of Oklahoma and Texas and parts of Kansas. We're going to watch it carefully because as the storm system races east tonight, we're going to see storms from central Texas through the Red River Valley of the South, through Kansas City and into Iowa. So I'm going to do this drive. Maybe I'll catch some of these storms later today. I don't know. We'll have to see how this all shakes down. But then you got this tomorrow. This right here shows us that Louisiana and Mississippi, parts of Alabama, this is the area that tomorrow is going to have the second highest risk, a moderate risk on the Storm Prediction Center scale here for severe weather, just after we saw this recently, all the severe weather we had in the same area. And it goes east on Thursday. So let's take a look at how this is all going to go down. The storm system really starts to show up tonight. Look at this. That's late today into tonight. And then as we go forward, the backside, snow back here, ice to the north. That's what the pink is. And the severe weather comes ripping through tomorrow through Missouri, Arkansas, Louisiana. It should cross the Mississippi between 3 and 5 o'clock and keep going into the Eastern Corn Belt. Now, Matt, don't get mad when I show you this, but by Wednesday night, see the back side of this? We might be getting some snow in your area and some strong winds. Ice if you're in this area. That storm system comes ripping through. Total precipitation out of it. We're looking over the next 7 days here. My buddies in Illinois are not happy about this. They want to get some fertilizer down. They want to get some field work done. We're putting down 2 inches of rain in this area. From eastern Oklahoma, eastern Texas, all the way down into the southeast, another chance for picking up several inches of rain. But you can see the back edge. We're drier west of there. And that's our problem. Because even when we look out there to 10 days and beyond, we see better moisture here, but not where we really need it in this area, and certainly not in California. Now, real quick, what do we see after this? Well, here comes the first system. Watch it with me. Rips on through. Little clipper comes in after that. And then we get a little bit of a downtime period until about next Tuesday when our next system starts to take shape. This is the chance of getting at least an inch of rain between now and April 8th. So you can see that through the lower Mississippi River Valley, through Illinois, Wisconsin, Michigan, Missouri. There's going to be a lot of places here that are not going to get a chance to get any field work done because of how much precipitation is coming through on these next couple of systems. We look on the temperature side of this in the near term. Everywhere that you see gray is an area that we expect the surface temperatures to get below freezing at some point in the next 7 days. To show you this temperatures, take a look. As I click play here, there's today's highs. As we get into Wednesday, look at all the heat building at Eastern Corn Belt while the cold air comes on the backside here. And then we go out there to Thursday, cold air really barreling through the Midwest. We start to moderate a bit over the weekend. There's Saturday into Sunday, but the colder air really tries to hang on into early next week in the eastern part of the country. Now, what about beyond that? We've seen some cooler signals in the east as we get into the middle of the month. But at this point, there's no prediction overall that we're going to just go over to a brutally cold April that's going to just not let us get anything done like we saw in 2018. But I just want to remind folks, especially if you're here in the Midwest, we're still anywhere between 15 and 30 days away in this area from our last frost. So we are still going to be watching for those overnight lows to dip down there below freezing. And if you want, in my morning reports, I actually provide a link to soil temperatures throughout the Midwest as well. So you can see those down at 4 inches and what to expect. But what I want to do in my remaining time today is I want to give you the long range forecast. And we're going to start first with this map. This was just released last night. It's going to start you out there about 10 days from now, April 7th, and we're going to look to May 7th. This is run by the best model in the world, the ECMWF. Now, what do you notice? It wants to keep the places that are wet wet. Wants to keep the places that are dry, dry, including California. It's got warmth here, and that's because it's predicting the jet stream comes in and dives like this, which means it's going to come over the mountains. So you're going to get compressional warming on this side. Plus it's dry, a lot of sunshine. Why is it cooler here? Well, jet stream winds coming in like this out of the north and northwest before they make the turn have some cooler air in them. Plus they're predicting quite a bit of cloud cover and precipitation. So you don't have the chance to recover quite a bit of heat. So this is mostly biased toward the front half of April, but there's a chance that we're going to see really tight windows in the Eastern Corn Belt this year, tight windows to get anything done. The West may open up sooner. It may open up to more broad scale warmth once you get into the second half of April, and things may go a bit quicker. But I'm going to be honest, I do not have a good grip on what the second half of April's temperature pattern is going to look like. I don't know. There's too many moving pieces, and I'm going to talk to you about what those moving pieces are as we near the end of what I'm going to share with you today. The biggest one is La Nina. Now look, remember we talked a lot about the jet stream pattern? When there's a La Nina, the jet stream tends to run over a big ridge here, and it dives like this. So we tend to be wetter east, colder and drier west throughout winter. And this is exactly what we've seen. But I got a question for you that we're going to ask and get an answer to. Are we going to see another La Nina summer or another La Nina showing up next fall or winter? Because historically, looking back to 1950, which is what this particular graphic shows you, La Ninas tend to be double dippers. You tend to get one in one winter, and then there's another one the following winter, like 73, 74, 75, 76. Or look over here, 95, 96, 97, 98. See it? Or excuse me, 96, 97. And then look at this one though. 98, 99, 99, 2000, 2000, 2001. That was 3 La Ninas in a row. And the question is, we just finished this one last year. We're in this one this year. Are we going to see another one? What's La Nina? This is cold water in through here. The cold water is the symptom. The cause is strong trade winds. When those trade winds are strong, a lot of cold water upwells in this area. Now listen, as I finish up today, we have to talk, and this is my second point, we have to talk about the cold water here and its importance compared to the cold water here and its relative unimportance. We don't worry about La Nina in summer because the statistical correlation with La Nina in Midwest summer weather is between 0.1 and 0.3. The statistical correlation between cold water here and here with summer Midwest temperatures and precipitation can be as high as 0.6. La Ninas control our winter weather, our spring weather. The cold water in the Gulf of Alaska governs what we typically see in summer. Okay, now that you know that, let's take a look. La Nina first. La Nina reached its first peak in December and a second one in March. Nearly every global weather forecasting center says that by the time we get into early summer, we'll have what's called INSO neutral conditions, so neither El Nino or La Nina. Some of the European models forecasts actually give us a weak El Nino by fall. There is only one model globally that isn't doing this, and it's the model we run in the United States. It's called the CFSV2. Now, the CFSV2 not only keeps cold water in the Central Pacific, but also in the Gulf of Alaska. The US model, the CFSV2, is the most aggressive on drought of any forecast model, and I'm going to show it to you in a second. Now, statistically, I know we're getting late in the talk and I just throw up these complicated figures, but statistically, by July, August, and September, the greatest probability for the ocean temperature behavior in the Central Pacific is for it to be neutral conditions. But the second greatest, about almost 40%, is for there to still be a weak La Nina. El Nino doesn't probably show up until here, November, December, January. That means we're going to be dealing with the summer where we might be talking about the lingering effects of a La Nina. But as I said, that may play second fiddle to the ocean temperatures in the Gulf of Alaska, which you've now heard me say many times. Let me explain for you. We've got records going back to the 1850s on the Gulf of Alaska temperatures. And what I want to show you is this. Look at the map on the right, the cold phase. The last time we saw cold water here was in 2008 to 2013. From 2014 to 2017, it was warm there. Recently, it's gone back over cold. And when it's cold, there's not a single place throughout the primary corn and soybean belt that doesn't have risk of drought. So what I need to ask myself is the cold ocean water in the Gulf of Alaska going to be a St. Peter's type disruptor? Or is somebody going to come along like a North Carolina and squash it? Got it? That's what we need to figure out. So let's do it and we'll wrap this up. Noaa suggests that we're going to have tight planting windows through spring in the eastern part of the Corn Belt. They expect drought to continue into Texas and start to build in the Great Basin. While they favor more mild conditions than cold conditions, there is no indication of just a full breakover to super mild weather in April that just alleviates all risk of a late frost. It's just not there yet. I don't see it. Noaa is just one of the 5 different forecasts I'm going to show you, though. Ready for the next one? This one comes from Columbia University. Same mild forecast as Noaa. Cooler in the Northwest, same as Noaa. But their March, April, May forecast keeps the eastern Corn Belt wet, keeps Iowa wet, and beats the drought back west for the 4 corner states into the high plains of Texas, Colorado, and Kansas. Let's keep going. Noaa's long-range temperature forecast. You see spring on the left, looks very similar to what I showed you earlier, but now I've got their July, August, and September temperatures, and they keep the hottest conditions compared to average anchored from Texas back into, well, through Utah, parts of Wyoming and Idaho. What about precip? They've got tight windows for spring planting here due to too much water, but drought developing in this area. And then July, August, September, they've got risk west of the Mississippi. Now you say, Eric, why? The reason why is because all of these models, and we're not even done looking at all of them, they were all initialized with drought in the areas that you see the forecasting drought. Let me keep going with this. This is the European model, the best model in the world. It says tight windows here, dry there, and it's wrong here. It's just wrong. Don't look at it. It then says summer, look, June, July, and August, split the country on the Mississippi River. East of it, wetter conditions. West of it, drier, hotter, extending all the way from Texas to the Canadian prairie. The only model that is super aggressive on developing drought for everybody is the same model that keeps La Nina around. It's the model we run here in the United States. And its spring precipitation pattern is very dry here and even more expansive in the drought for summer. Now, we look at all of that, and we need to add some meteorology to this. What can we do with this information? Well, what I made a case for was that if we're going to see where drought is going to go, we need to know 2 things. Where is it currently? And what about those ocean temperatures? Those are the only 2 factors we've got. Because I always get asked, well, what happened in 2012? It got really cold here, and stayed cold there, from the Baja of California all the way over to Hawaii. That's the risk area. So let's do a forecast. These are the ocean temperatures in March. When I click play, you're going to see the map change, and this is going to go 1 month at a time from March all the way to September. So here we go. Now, I hope you all focused on what I wanted you to focus on without me telling you. It's the Gulf of Alaska. Did you see how the warm water encroached east, getting rid of the cold signal right where I'm drawing this zigzag? What I'm going to tell you is if this map verifies, in other words, if it's right, and that water goes back to normal, and the La Nina shrinks and heads south, that's going to take drought risk from the Midwest and just keep pushing it west with time. And that's the main thing we've got to watch. Now, the reality of it is if I could perfectly predict this today and tell you exactly what was going to happen, or if anybody could, they wouldn't tell you. Matt would no longer have my cell phone number or my email. And that's because I wouldn't give it to anybody. I would make a couple of trades and retire. But the reality of it is that just like the NCAA tournament, it's a nonlinear and chaotic system, and it is very much prone to error. Would you like to see how terrible these models are and why I write a daily report? Let me finish with this. This was the forecast for March, April, and May last year. Wet in the Northwest, wet in the Canadian Prairie, really wet in the Great Lakes, dry in the South through the lower Mississippi River Valley, and then dry in the plains back to Colorado and the Four Corner states. That's the forecast from the US models. This is what happened. It was dry in the Northwest, got that wrong. It was dry around the Great Lakes, got that wrong. Plenty of precipitation in this area where we forecast drought. This is the way the atmosphere works. Things can come through and disrupt the pattern. And my job as an atmospheric scientist is to stay on top of it, monitor it, tell you the confidence in it occurring, and then you can make a decision based upon it. And that's why we go back to the beginning today, where the very first slide I had contains my report. And I'll just send it to you real quick because that web address is here. And I'll come down here to the chat and we'll put into here that link. So let's take some questions. I saw something come up in the Q&A. Dan asked a question. Does the extreme solar flare activity recently have any impact on your forecast? Dan, great question. My answer is no. And I'll tell you the reason why. When we look at those factors that tend to control weather, we have our factors of kind of first importance, those first order factors like La Nina or the cold ocean temperatures. And then the drought, we have our second order factors. We have our third order factors. Our third order factors is where solar activity comes in. In other words, the changes we see in the solar activity is not of a large enough magnitude to become a dominant driver of drought issues. I know you might hear other people say otherwise, but I've studied this for 20 years. I've talked to all of my colleagues at major universities. You can't find it in the peer-reviewed literature to say that that's a situation. Okay, so I want to make sure I'm clear on that. Mitch asks, what's the best place to watch the current jet stream and future jet stream forecasts? Yeah, Mitch, I'm going to be biased toward my own website, but can I show it to you real quick? Let's see here. We go here and I go to this link, Atmos, oh no, not Atmos, I'm sorry, Ag Weather. It's agweather.com /national. And by the way, if you sign up for my daily reports, you just get access to this. So this website's one I built and it's got all my favorite maps in it and they're all labeled so you can see it. But you see over here, there's a kind of a table of contents. Come down here to click on upper level winds and click on it. You'll be able to see vorticity if you want to learn about that, or you can come down here to troughs and ridges or slide a little bit farther south and actually see the wind field. So you can click right here. And what this will allow you to do is grab the little slider bar and see how the jet stream level winds change over a 10-day time period. Okay. But if you're interested in those troughs and ridges, come right back up here, click on any of these three. I'll click over here on the GFS ensemble. And now you can see in blue where the ridges, where the troughs are, and in red where the ridges are. The pattern's active right now, man. It's really active. We're going to watch this carefully through the beginning of the month of April. That's what you just saw there. But again, that website, ag-weather. Here, let me put it in the chat. There we go. Great. James says, so the solar flares are a 10th seed. They're more like a 5th seed, right? Because the 5th seed always loses. Anyway, I want to show you another cool thing about this site. Matt, tell me the town. You're in Des Moines, right? So this is kind of fun. So over here on the right-hand or left-hand side, I got to get my directions right today. There's a little box here. You can click on it and start typing in a location. So if we type in DES, you'll get Des Moines. It'll put a number in there. That number is the index number I use. This actually means that Des Moines is the 92nd largest town in the United States, if you ever wanted to know. Click on it, and what it'll do is it'll give you a forecast. First thing it does is it gives you a National Weather Service forecast, which is right here. So this gives you your National Weather Service forecast every day for the next 7 days. I just hit their API and you get that information. It takes about 7 or 8 seconds, but let's go back and it should show up here. Give it another second. Must have some people hit my server pretty hard. There it is. Took about 10 seconds that time, but you got down right here what you call a multi-model forecast. So you'll get this one first, this one second. And this will actually show you what every one of the weather forecast models is predicting. So Matt, to tell you how tight windows are going to be, we got precip coming tonight into tomorrow, another chance on Saturday, another chance next Monday and Tuesday for a grand total in your area of about 1.3 inches. The GFS model, so that was the European, it's got the same events, but it's really putting a bunch of precip down at the end of next or the middle of next week, up to 2.88 if these two systems verify. You've also got information at the bottom on wind speeds. So if you want to know wind speed and direction, gusts and everything, it's there. Soil temperatures, soil moisture, I've got it all mapped out. So yeah, we don't want to do anything just yet. This red line tells me that my soil temperatures are down below 50 quite consistently here. And then at the bottom, I've even got historical data. So look, this is your precipitation so far year to date. You're at 89.95% of normal, but you can see last year, I've got it shaded how dry it was last year in parts of Des Moines, especially the end of the year right here. And then if you're interested in GDUs for Des Moines, see these blue bars? Each one of them represents a day. So for example, the last day for a spring frost is on average around April 20th to April 23rd. But you've had frosts as late as the 13th of May. So then we'll start accumulating your GDUs and you'll be able to see how they stack up compared to the previous years. It's all just a free tool that's there for your use, and I hope you get to use it. Dale asked a question. In Southwest Minnesota, would you advise hail insurance every year? Absolutely every year. I would never mess around with it in Southwestern Minnesota. To be honest with you, I would, if it was affordable and it fit into your plan. The thing about it is that, you know, hail events are streaky by nature, but I would never want to go without the protection of having it. That's my own personal thing. But I'm going to tell you something, Dale, of every type of severe weather that you can come into contact with, I think behind an ice storm, hailstorms are the scariest thing for me. Because I've storm chased and I've been in big hail, and it's absolutely terrifying to watch the atmosphere throw down ice at you at 150 to 200 miles an hour. So that's why I tell you, yes, buy the hail insurance, because I just don't mess around with it. All right, Matt, I've got the questions answered. We've gone over a couple of minutes, but I'll turn this back over to you.
Okay. Well, I thank you very much. It looks like you covered a lot of topics very quickly, and from what I understand, it looks like we're a lot of moving parts yet. We're definitely very dry in the western corn belt. Hopefully, as the season progresses, though, that we'll see more precipitation come in and improve that. So it doesn't look like we had any other questions. So I thank you very much for your time. Really appreciate it, and we'll make this recording available to people that registered. So, any other final comments?
No, I think we got it all out on the table. It's just to see how it all stacks up and falls down later. So that's why I look at it every day. It's the same thing with you in the markets. There's a new story every day. We stay on top of it and try to keep folks informed so that we can be some sort of consistency with all the chaos that happens. And that's a business we're in.
Well, very good. Thank you again. We appreciate it. Thank you, everyone.
Yep.
Have a good day.